our identity provider and service provider. In an OIDC or OAuth scenario, we have client and authorization server. So here we call the applications which rely on an authorization server for a token as clients. So our service provider will take the role of a client, and the identity provider, which was Okta before, would become an authorization server, and it would help user, or let's say that it would help the applications get an authorization from the user in the form of a token. So the token is nothing but an authorization from the end user who is authenticating. And why do we need an authorization like this? Is because the token contains some information about the user, and we need to take permission from the user before sharing this information with the third-party applications. So you might have accessed nowadays, like if you go to any website where you have an option of third-party sign-in, like Google sign-in or Facebook sign-in, and you see that it requests you to click on accept or deny, and it gives you a message that Google will be sharing your name, date of birth, or email address with this third-party application. So have you seen this kind of screen before?
Yes.
Yes.
So that's very well. You have used OAuth protocol before, and that is called authorization. So when you click on accept or deny, if you click on accept, mostly you are authorizing Google or Facebook, whoever is your authorization server, to provide these information to that third party application where you want to log in, and Facebook will then generate a token, or the Google will generate a token uh, which has those information. So Google and Facebook takes an authorization from you, and they are playing the role of an authorization server. They convert your authorization into a digital format called token and shares it with the application. So this is OAuth. Here you play a role, the user plays a role of resource owner, because the information which is exchanged in the form of a token is is something which belongs to this user or is owned by this user. So the user is a resource owner, and the information are the resources. So your name, your date of birth, your files, emails, songs, whatever you have in your possession, that becomes your resource, and you are a resource owner in this scenario. So what are the parties we have here in OAuth? We have resource owner, which is the user himself. Then we have clients, which are the end application, which want these information. We have authorization server, which can authenticate you and take an authorization in a digital format and share it with the applications in form of a token, which is Okta. Then we have the resources, which are your information. It can be your attributes, it can be your files, whatever, right? Any confusion so far?
No, I think we're good.
No.
Okay. Okay, so let's now compare. So during this session, you will see I'll mostly try to like use the idea of SAML and try to extend it into OAuth so that you can understand it very clearly. So if we use the idea of a service provider initiated SAML flow, then in that case, a user would first go to the application or application URL, and then application initiates an authentication request with Okta. Is that correct?
Sorry, can you repeat that again?
So in case of a SP initiated SAML flow, a user would need to go to the application URL first, and then the application would have to generate a request to the identity provider, which is Okta in our scenario. Is this correct?
Yes.
Yes.
And what do they need to include in the request? And how would Okta process this request? If you could explain me a little bit about the SP initiator flow.
Like meaning what the service provider needs to provide to Okta?
Yes.
The entity ID, destination, assertion, consumer service URL.
And how does Okta use this information and process the authentication request?
Through the response. So Okta will
No,
confirm.
a response. Okay, a response is generated after authentication. This request has arrived, right? As of now, user is not yet authenticated. How is Okta using this information, or how is Okta using the information in the request and authenticating the user?
Is it using a single sign-on file? So they'll share a single sign-on file and Okta will confirm.
Single sign-on file. No, I haven't come across that.
Um, is it, did they use the entity ID to verify the SP's identity, and then they look at the request that the service provider is asking for? Once they have the information, then they will send the response whether the person is verified or not, and they'll send it to the ACS URL.
Yeah, you are correct in this case. So yes, they would use the entity ID, which is in this term issuer of the request, and they would verify the app which itself requesting for authentication. And if there is such an integration in Okta, it would go ahead with user authentication. So it would prompt the user for an authentication. Once user authentication is successful, then it generates a SAML assertion and delivers it to the ACS endpoint of the application. So, and that ACS, sorry, that assertion contains information about the user and the authentication involved, whether it was successful or not, and who should be receiving it as audience, right? So in case of SAML, most of these informations are pre-configured. Like say, if I need to share your first name, last name, group, or whatever in the assertion, we pre-configure this information in Okta. But in case of OIDC, it may be that sometimes app would only need your full name. They might not need your date of birth. They might not need your address, your email address or your street address. They only need partial information. And there can be a scenario when they need more information. So in case of OIDC or OAuth, this information which Okta will share with the application will become dynamic and would be controlled using a parameter called scope, which in case of SAML is not there. For SAML, the information are static. So whether you are doing an authentication 100 times in a day, the information exchange between Okta and the application has to be pre-configured and has to be the same. But in case of OIDC, that can be a variable information because an application may request for, let's say, they can request for your profile, which contains your first name, last name, your display name, and your locale. Then they might request for your street address. Then it will contain your city, state, zip code, and so on. So until and unless they require that information, they might not request Okta for it. So Okta can have an option of sharing partial information versus full information or more information. And that particular parameter which controls this is called as scope. And going forward, we'll see how the scopes are used in an OIDC calls when we make the request. Again, similar to. Mhm.
Sumit, I apologize for cutting you off. I had a question. I was under the impression that in SAML, the the uh, the credentials of the user aren't shared. So is it safe to assume that in OIDC that is something that is shared? I mean, because you're talking about different attributes. Um, and I remember in the prerequisite course that it was listed that SAML is more secure because the credentials aren't actually shared. So would OIDC then be in the same group as SWA because the credentials are shared?
No, credentials will never be shared with the application, be it SAML or OIDC. So SAML or OIDC would only share the information about a user, like the attributes of the user, not the credential. So credential has not to be shared. That's the whole purpose of having these protocols in place. When you talk about SWA is not actually a protocol. That's just built so that you can have your app centrally, even if it does not support these protocols, and it just acts as a password manager. So that's why in case of SWA, the passwords are shared with the application, but in OIDC and SAML, there is no sharing of credential to each other.
See, so hence the encrypted token or the XML file because you're not actually sharing credentials.
Yeah, so that's why we are sharing a token. So we are sharing a proof of authentication. And that proof of authentication is a token itself, which gets issued by Okta. And in case of SAML, we share a SAML assertion, which again gets generated by Okta, and it acts as a proof of authentication. So there is no requirement to share the credential at all.
Okay, then maybe I didn't understand. What does how does the scope in OIDC alter the information that is passing
Sorry, can you
being
repeat it once
passed?
again?
How do the scopes in OIDC how do they alter the information that is being passed?
Yes, so as I said, so let's say that you want information about a user. Now, let's say that there are seven information about a user, seven attributes. You have first name, last name, street address, city, zip code, phone number, and so on, right? And during the authentication, you might just need the information as, let's say, your first name, last name, and your email address. That is enough for you to get authenticated to the app at that point of time. And let's say that these three information comes in a scope called OpenID. So when application just want to authenticate you, they might request Okta for a scope called OpenID. And Okta knows that whenever somebody requests me for a scope called OpenID, I only need to share three information, which is first name, last name, and email address. So whenever application requests for this scope, it will share these three information. Let's say application need more information down the lane for some other activities which application is performing, and now they need your street address or your phone number as well, which was not included when you did the initial authentication. In that case, what application can do is application can request Okta again, and this point of time, they can include another scope. So they can say OpenID as well as let's say profile, which contains the other information. So now Okta knows that there were two scopes requested, OpenID, which contains first name, last name, and email address, and profile, which contains all other information. And Okta can share all of these information in a single token to the application.
I see. Okay, so okay, now I understand. Essentially, please correct me if I'm wrong. In SAML, there is only one scope. It's just like you said, it's static set of attributes that are sent. But we can expand upon that through OIDC. It can be different. Can be used for different things.
Yeah. So in SAML, when you configure the app yourself, you need to specify what attribute you would like to pass. And so have we configured I think we have configured additional attribute in SAML before, right?
Sorry, could you repeat that, please?
Did we configure additional attribute in SAML during our sessions?
That I am aware of.
So we all know how to configure SAML application at least, right?
Yes.
Yes.
Okay. So assuming this is a SAML application, right? And if I go to my integration phase, after giving the application name, I go to the SAML settings. This is where I need to provide the SAML information. And if you see, there is an option of attribute statement, which is optional. So by default in SAML, there is only one required information, which is the application username, which we also call it as name ID or SAML subject. So there are three different names for this. Application username is something which Okta calls it. The real terminology is SAML subject or name ID. So this is the only required information, and it should match with the username in your application, which we have already discussed. But apart from this required information, you can also ask Okta to share additional information like your first name, last name, and we can configure those additional information here. So let's say this application requires your first name, your last name, and your phone number. And these information are stored in Okta attributes called first name, last name, and phone, right? So there can be two things. How would the application understand the attribute names? So what application does generally is they provide you the name which you should include as an attribute name in the assertion and the value against it. So the value will be fetched from Okta attribute, whatever is the configured in Okta. And then here in the name, this is a string box where you can type the name of the attribute which your app expects. So let's say my app expects first name in this particular format. And Okta definitely stores this attribute in this format, right? So user.firstname means to fetch the first name attribute from the user profile, and it will have a value. Let's say it will have the value called Sumit, and it will be sent in the SAML assertion as first name equals to Sumit. So this will become like this in the SAML assertion. Okay. And similarly, if you want to share last name, so you have to type in the name format which your application expects, and then the Okta attribute relevant to that attribute. So it would become this, right? If you want to pass phone number, let's say your application is calling this as a phone number, but Okta call it primary phone, then you will just type here user.primary phone, which will give the value as phone number equals to +1, whatever. All right. Is there any question on this?
No.
Okay. Now, whatever attribute you're configuring here for SAML, every time this information will be passed. If I do the authentication 100 times in a day, these three information plus 1, 4 will be passed in the SAML assertion if I have these attributes. If I don't have these attributes, then it will be just passed as blank. But there is no way to tell Okta to only pass first name and not last name and phone number. And again, in the different time when I'm authenticating, now pass only last name or phone number and not the first name. There's no way in SAML to tell that, but in OIDC we can. So like this is how we can add more attributes in SAML, but whatever we configure here will be passed at all the time. Any question?
No.
Nope, not yet.
No.
Okay. Now, what are the different types of flows we can have in SAML?
We could have the flow originating from the service provider and then one originating from the identity provider.
Okay,
Is that
so
what you're
two
referring to?
flows. Yeah, so two flows. One, we call it as IDP initiated, and the second one is called as SP initiated. But in OIDC, generally it's ever increasing. Now there is no limit of number of flows you can have, but generally there are four base flows which we have in OIDC. It's named as authorization code flow or authorization code grant, implicit grant, resource owner password grant, and client credentials grant. So these are the four base grant types in OIDC. Similar to how SAML has only two, which is service provider initiated and IDP initiated. If you haven't understood the names, I'll just type it here. So flows are also called as grant type in OIDC. Okay. So these are the four. Now in SAML, the two flows, SP initiated, IDP initiated, um, does not alter the process of authentication a lot. It only tells the behavior from where the request originally initiates. But here in OIDC, this will alter the process of authentication a little bit. It will, some will have more steps involved for the authentication to go through. Some will have less step involved. And the information also contained in the token would change based on these flows. And there are different reasons why one would be using over the other, and we will be discussing that. So for today's session, we will start with the first flow called authorization code grant, and let's understand that. So let me bring my favorite tool, draw.io. Okay. So let's assume this is a user and this is the application which the user would like to access. And here we have Okta. What is the role of Okta here in OIDC?
The authenticator,
Authorization,
authorize.
authorization server.
Right, authorization server. Okay. So this user would like to access this application. Now, similar to SAML, this application relies upon a third-party system to authenticate or provide the information about the incoming user. So this app would not on its own. This would rely on Okta, which is our identity provider system. Now, so what this application would do is similar to what we have seen in SAML also, it will redirect the user towards Okta, correct? Now, Okta has to authenticate the user. Once authentication is successful by means of username, password, or yeah, so once the authentication is successful, whether it involved username, password, or multi-factor, it would then create the information in a SAML assertion or in a token and share it with the application. So this token would now contain information about the user, which the application can use and can identify the user authenticating towards it and then bring in the relevant services this application provides. So if the user is an administrator, it can give the administrator access in the application. If the user is an end user, it will give the end user access and so on, right? Any confusion so far?
No.
And is this similar to SAML so far?
Yes.
It looks like it, yeah.
Okay. So what we call this line in SAML, the first one,
Request.
Request.
what request?
You're requesting, the application is requesting Okta for the entity ID, the destination, and the ACS URL.
We call this as SAML authentication request in SAML, but in OIDC, this will become as authorization request. So the application would make an authorization request to the authorization server, which is Okta. And based on this authorization request, Okta would first need to verify the user themselves. So Okta will ask the user to enter a username and password. Once this is done and the authentication went successful, it will then retrieve the user profile from the Okta directory. So users are generally stored here in directory, right? And they have the attributes. So let's say Tim is a user. So Okta would be able to fetch this profile of the user and then create a token with the required information and then deliver it to the application. But it will not directly deliver the information like SAML to the application. It will it will do some verification first before providing this information. And that's where the difference would come in. So here in the second one, where it could have been a SAML assertion, in case of a SAML, it will not have a SAML assertion or a token. It will have something called as authorization code. So have you seen that whenever you're performing some authentication, it might send you a OTP on your mobile phone, and you need to enter that OTP to process further, and then only authentication completes, mostly in case of a bank transfer or something.
Yeah.
Yes.
So Okta, which is the authorization server, would also first generate OTP of a similar kind. Like it will not be a 4-digit or 6-digit OTP. It will be alphanumerical OTP of 16 to 32 characters, and it is called as authorization code, which will be sent to the application. Now, application has to prove that it has received this authorization code back to Okta, similar to how you do in case of a mobile OTP. So you receive the mobile OTP from that authenticating system, and then you provide the OTP back to the system, and then it confirms that you own the mobile in your possession, and then it lets you authenticate. So similarly, when this authorization code is received by the application, they have to confirm that they have received this authorization code, so they know that the endpoint where they are requesting for tokens to be delivered are are in the possession of the application. So Okta is sending it to the right location. It's not being sent to any attacker or something, right? So Okta would first share an authorization code like a limited time OTP, and then application has to return that OTP back to Okta. So they have to come back to Okta after they have received this OTP, and they have to reshare this OTP with Okta.
Sumit, is this OTP sent in the place, like if you were in SAML, in place of the entity ID? Is it doing the same thing there?
No, entity ID is like a fixed static value. It is just to identify the application. Entity ID is similar to client ID in OIDC, which we haven't discussed yet. It's not replacement of OTP. OTP would be like a one-time password, right? A one-time code. So it will be changing every time you authenticate.
Okay. Yeah. No. Because is this am I thinking correctly that the identity ID is how Okta verifies the service provider? Um,
Yes.
so
It
in
does
this.
not verify, it identify.
Oh, I see. Okay, okay. It's just an identification that okay, we are getting a request from this place, but there's no actual um, verification done.
In case of SAML, like there is no as such verification done. It's just an identification. Yeah, for verification, we had something which we discussed during our SAML class, which is called as certificates, which are optional, right? So certificates were there. If Okta really needs to verify if it's coming from a genuine source, then there is a use case of certificate in case of SAML. But that is an optional parameter. It's not a required thing in SAML. But here in OIDC, especially in authorization code grant, this verification that the tokens would be delivered to the right endpoint is a mandatory step. Okay,
Oh, okay, I see. Thank you. Thank you for clarifying that.
no problem. So this application has to return the same authorization code which it received from Okta back to Okta. So this would confirm that the authorization code went to the right endpoint. The application was in possession or ownership of that endpoint, and Okta would then will be able to issue the information in the so-called token, which then application can make use of to process authentication further. So this will become a step 4. Tokens will be issued. So this now completes the loop or the cycle. Now, is it similar to SAML?
No.
No,
And any question do you have on regarding these 4 steps?
not at the moment.
Okay.
So would the
So let
user
me.
be a
uh,
sorry, would the user be a resource owner?
yes, the user will be a resource owner because the token contains the resources which is directly which is of the user, and hence user is called as the resource owner. And here, when user is authenticating to Okta using the username and password, um, in against this authorization request, then user is authorizing Okta to share these resources with the application, basically.
Okay, thank you.
Yeah, similar to like what you have seen in Google, right? Whenever you do a third-party authentication, Google takes a formal authentication from you. Okta will not take that formal authorization, but Okta just assumes that. Okay, so if I go to google.com and let's say some screen. So I'm talking about this, right? So I'm not sure if it's clearly visible. Can you see this?
Yeah.
Yeah.
Yes.
So this is like a formal consent which Google or any other consumer-based authorization servers would take before sharing your information. And this is only one time. Only for the first time you access that application, it will take that consent, and after that, it will store that consent. So it is saying that this application called IAP Desktop, it wants to access your Google account, and then this will allow this application to see, edit, configure, and delete your Google Cloud data and email address of your Google account. So these information, like, or these permission, which Google will be sharing to this information, to this application, are called as scope. So here, basically, Google is allowing a view scope to see the data, edit scope so that it can edit the information, and configure again, similar with edit, and delete as a scope so it can delete the resources. So this application will be able to modify the resources. And this is another part of OAuth, which SAML does not provide. So apart from only sharing the information, OAuth also has a capability of using this token to perform action on your resources. Like if it's a file, I can read the file, modify the file, or delete the file. So I can perform entire CRUD operation based on this token. Or I can just see that file as information, which we have seen in SAML. But here, when we go to that part, we will see we have more functionality in OAuth in that case. And this screenshot just confirms that if user clicks on allow and authorize and an access token is generated, then that token allows this application to perform following actions. Okay. Then
Hey, Sumit.
this is, sorry, yeah, go ahead.
Um, you said this is a one-time authorization. What happens in case, like, if the user's password changes or something? This authorization is still valid, or they would need to reauthorize?
No, this authorization will remain valid even if user password changes. Until you revoke the authorization, this will remain valid.
Okay, and where would you remove the authorization from? Would it be through Okta or through Google?
So in case of Okta, yes, it will be through Okta. In case of Google, it will be through Google. So whatever you is your authorization server, that authorization server will store all the authorizations you have granted so far, and you will have an ability to revoke them.
Okay, thank you.
So unlike the previous example where you were able to modify the resource itself, here this is a simple example where an app called example would like to see your basic profile info, which basically your display picture, first name, last name, and your email address. So it has basically requested for two scopes, and it is taking a permission from the user to allow those scopes. and then Google would share these information with the example application. So this step itself, where you click on this allow, is called as authorization. And this happens after you have logged in using your username and password. So you log into username and password to confirm that you are the real person. And then you click on allow and you give your formal authorization to Google as authorization server. In our case, it will be Okta as an authorization server. And then the tokens are generated with the approved scopes. So you are approving these scopes, and with these approved scopes, the token are generated. If at any point of time, this application called example app now also want to read your phone number, which was not approved, then you will see this screen again. And it will now also include view your phone number, and then you have to click on allow. So that is the second time you will see the screen for the same application when there is a modification in the scope. Okay. Yes, no, maybe.
Got it.
Yes.
Thank you.
Yeah.
But this will be shown to you when you're doing Google as authorization server. When we come back to Okta as an authorization server, this is mostly an enterprise application. You will not see a screen like that. By default, it assumes that you have clicked on allow if you authenticate and if you're assigned to that application. So if you're assigned to the application, let's say an OAuth application, whatever, then Okta assumes that you have already clicked on allow. So there is no consent screen like this in Okta, which you can see, but the token which is generated is considered as approved scope because you allow those scopes as an administrator in Okta here. And we'll see how you do that, but you will not see a screen like this. Okay. Okay, now can you tell me in case of SAML in step 1 where I am performing the authorization request, which endpoint of Okta does this request need to be made by the application?
Sorry,
Could you
I
repeat
didn't
that?
understand the question.
So if we assume that this is a SAML configuration, then which endpoint of Okta an app will redirect or make a request for SAML authentication?
The service provider?
Service provider is the application itself.
Sorry, I didn't understand the question.
My question is, when you perform an SP initiated request in SAML, app has to make an authentication request to Okta, right? So which endpoint of Okta will the request need to be made?
Would it be something to do with um, the the descriptor, like the IDPS SSO descriptor?
That is a very different.
Could you repeat that? Your voice was a little fuzzy.
When an application makes authentication request to Okta, which endpoint of Okta will they make a request? Will they make a request to okta.com, okta.com/login? Which endpoint will they go to make this request?
The SSO URL?
Right. So they will make a request to the SSO URL of that application, right? Which will be given to you from Okta when you configure this app. So when you have configured this app, let's say Salesforce in our case, and if you go to sign on, and if you click on SAML instruction or whatever, you see that an identity provider single sign-on URL is given to you. And this URL is only for the Salesforce application. If you see, it also contains the name of the application. If I change the application to some other application, if I close this and if I go to other application, you'll see the URL will also change. So this has a now different app name, right? So this is the endpoint where the application will make a request to Okta and ask Okta to authenticate the user. This is called IDP, single sign-on URL. This is per application and it is generated by Okta. Okay.
Yeah.
Yeah.
So in this case, there has to be a similar URL from Okta where Okta can receive the authentication request or authorization request from the applications. So instead of that is being a single sign-on URL in case of SAML, we call that URL as authorization endpoint. So there are multiple endpoints in Okta. The first being authorization endpoint, or let me just name it as /authorize. Okay. Or for your example, let it fit like this. This is the authorization endpoint of Okta. This is just a demo. It's not a real authorization endpoint. So when we configure a real application, this will change. But for timing, let's assume this is a real endpoint. So this is the authorization endpoint where application has to make a request. And then once the SAML request is processed, when Okta has done the authentication and it needs to send a response, which URL of the application will Okta send the SAML response?
The ACS URL?
Right. That here is called as redirect or callback URL. So similar to the ACS URL, we have redirect URL or callback URL. And ACS URL belongs to Okta or application in SAML.
Yes. No.
I didn't get you.
Yeah, I think it does.
Who is the owner of the ACS URL? Is it
The
Okta or
service provider, the application.
correct? Here also it would be the client. Service provider is called as client in OIDC. So a similar URL like that called redirect URL or callback URL is there in OIDC, where this authorization code will be sent, and this is owned by the application. Then when application need to share this authorization code back with Okta, they need to again confirm it at a different endpoint of Okta, which is called as token endpoint. So now this time the URL will change and it will become my example.okta.com/token. And we call this endpoint as token endpoint. And this is where application will make a request for actual final token by resharing this authorization code, which they got in step 2. So in step 3, they are resharing this authorization code back to Okta, and this is done at the token endpoint of Okta. So this token endpoint belongs to Okta, and Okta will receive this authorization code from the application. Will try to match both of these authorization code. If it matches, then it will be able to issue the token in step 4. Again, this token is being sent to the application. So it is being sent to the redirect or the callback URL of the application, which in case of SAML was ACS URL. Any question?
No.
Okay, so
Actually, I do have a question. So then, in step 4, what the tokens they're sent back to the same redirect or callback URL?
that can change. That is again another feature of OAuth. But let's for the timing, let's assume yes, it is sent to the same redirect URL. Okay, so can one of you explain me the end-to-end, all the 4 steps, which is shown here, if you understood the process?
Sure, I can attempt it. So first, the user labeled actor, he's trying to access an application. So the application will then send an authorization request to Okta, and it will ask Okta to verify the identity of the user. What Okta will do is to verify the application, to verify that the person is indeed who they are dealing with. They will send an authorization code. As you gave the example of a OTP, when that code is verified, it will be sent back to Okta. Then Okta will verify. Once they verify that it is this person that they're talking to, or the request is coming from the right person, or the right I guess application, then they will verify, and then they will get the information encrypted in the form of tokens, and then send it back to the application so that the person can be verified.
Right. Yeah, the only thing which you could have included is the endpoints also, but yeah, you're right. The process is correct. This is what it involves to generate a token, and this process is only for authorization code grant. So we discussed there are 4 grant types, right, in OIDC or OAuth. So this process which we discussed today is only for this one. When it comes to this one or this remaining 3, you will see the steps will change. Some will have more steps, some will have less steps. So this is totally a step for authorization code flow.
Sumit, just so I can be a little bit of a perfectionist, you said I could have included the endpoints. How would you want me to describe that? For example, would I say for step number 1, I would say the client would issue an authorization request to the authorization endpoint in Okta?
Yes.
Is that how you want me to say it?
Yeah, you can say that. So that you are defining, right, who is making the request and to whom. When we say a client makes a request to Okta, there are numerous endpoints in Okta. These are just 2 I have listed here, but there are other endpoints in Okta as well. So if you want to see, there will be at least 7 to 8 endpoints, right? So we need to know, be specific where the request will be sent. Like in case of SAML, it is only the single sign-on URL which is there to receive your request. If you make a request to any other endpoint of Okta, it will not be facilitated, right? Sorry.
I see. Okay, so we would be completely lost if it was the way I described it.
I'll not be completely lost because I do understand it, but if I ask you now to make a request for OAuth, and if I don't tell you to make a request to authorization endpoint, you would be lost. So, okay, so these are different endpoints which Okta has, right? At least. And you have one authorization endpoint, which is this. You have a token endpoint, which is this. You have a registration endpoint, which is this. There is a JWKS endpoint. Then if you would see, which is not included here, device authorization endpoint, then you would have user info endpoint, you have introspection endpoint, you will have token revocation endpoint somewhere here. And let's see, revoke. Yeah, revocation endpoint to revoke the token or the authorization and so on. So there are so many endpoints which Okta has. So when you say make a request to Okta, which of these endpoints you have to be specific because these different endpoints have different functionality. So authorization has different functionality than revocation. So when you make a request to this endpoint, it just deletes your token. So the token which was issued before is no longer valid.
I see.
Okay.
Okay, thank you.
So you need to make a call to this endpoint whenever you are doing a logout. Because at that point of time, you want to delete the token which was issued before and you want to invalidate that authentication.
Okay, very interesting.
All right. I'll end the session here today. And tomorrow we would first configure a demo app and we'll see this in action and then we'll move to the other grant type. So if this is clear, the other would be very easy for you to understand. Because it will have most of the steps will be same, only a few information will be changed here and there, and then the configuration would be quite similar. Okay.
Sounds good.
Okay, yeah, that would be great.
Do you need this? You can also get this like diagram from Okta document itself. So if you go to Okta Authorization Code grant, you can get the diagram, which is a better diagram than mine. Here in the Okta documentation. So if you scroll down, this is how it shows in Okta, right? It tells you where to make the request and everything.
Yours looks easier.
Yeah. So you can refer to this diagram. You can also go through this documentation, and this is not for authorization code, go for authorization code. And yeah, this is the authorization code flow. And you can see the step 1, step 2, and it has more, it is showing you more steps because it is more granular, which we will see in our next session. But yeah, you can go through this documentation that is helpful for your study. All righty, if there are no questions, thank you for joining the session today. We'll again connect tomorrow.
Thank you for your time.
Yeah, thank you very much.
Thanks so much.
Thank you. Bye-bye.
Bye.
See you tomorrow.